Okay, this is a review of logs, and we're doing officially it's worksheet 16, which is logs and exponential solving. Day 3, I think? I think it's day 3, or it could be day 4. Does it say day 4 on it? Couple. Oh, okay. It's day 4. Thank you. All right. So, and then we have a day 5 tomorrow. So, by the way, I love this. Tomorrow, last day of new material. You won't have to learn anything more in Precalc. You just have to review what you already have. Tomorrow's your last day. After that, it's review for this test and then a test on Friday. And then, after that, it's a optional cumulative test. Why would you want to take it? Only if you need a retake. Now, the only people that should take it. And you can retake just one section. So, like, let's say you bomb this test you're going to take on Friday. You get an insta retake, which is really rare in this class. You know, usually it's like 3 weeks before you can retake. You'll have optional right away. You can take a retake on it. Personally, I'd rather just do well on it first. Looks better in the grade book. Anyway, and on the retakes, usually your B that you get is a B minus. So, better to get the regular B the first time, the 85% B. Okay, so anyway, that's the next few days here, and after that, of course, we're studying for the final, and then you take the final. So you take it early. We've gone through that. Yes. Today is the cumulative. I don't have the date for you on the cumulative. I can just tell you this test is on Friday. I believe we review on. Well, I know we review on Monday. I think it's Tuesday of next week. Could be Wednesday, but it's in that neighborhood. And it's optional cumulative for those that need it. Yep. It'll just be a review day. It'll be a quiet work time. You can come up and ask me questions while other people take the test. All right, so let's talk about the one on the board. This answer is very simple. What is it? 17. Because the two bases match, the base of this whole exponential and the base of the log are the same, and therefore the answer is this part right here. All right, there's a lot of different kinds of problems we got to prepare you for. What if there's logs on both sides like this? Log base 2 of x plus log base 2 of 10 is equal to log base 2 of 200. Would you please condense it down so there's only one log on each side? And if there is only one log on each side, it's sort of like the logs are going to cancel. Not exactly that, but close. Did you get it down to log base 2 of 10x is equal to log base 2 of 200? Okay, now, do you see? All I did there was take this x and this 10 and make a multiply out of the add that we had before. That's called condensing. But now that these can kind of cancel, they don't really cancel. All that really happens is that if the bases of the logs are the same, then the arguments must be equal. So that equals that. It's just kind of nice to think of it as when this disappears, there's still an equal sign there, right? And then the answer must be x equals not 2, but 20. Always check your answers to make sure they actually don't crash your function. So if, for instance, this had been a 5 minus x in the argument, when I put in the 20, it would cause a negative in the argument, and you don't want that. So anyway, watch out for that. This particular one does not crash my original function. So I'm okay. It worked. All right, let's do one where you don't have a log on the other side. Log base 7 of x plus log base 7 of 7, and I'm going to see if anybody gets sucked in on this one, is equal to 4. All right. Now, I know some of you are going to do this one way, and some of you are going to do it another. The red way, just say these two are the same, so I can put them together. Log base 7 of x times 7 is 7x equals 4. And then you do a rewrite. 7 to the 4 equals 7x. And then I divide by 7 on both sides. 7 to the 4th divided by 7. Ooh. Can I simplify that? 7 to the fourth means 7 times 7 times 7 times 7 over 7. Can't one of those 7s cancel? So the final answer is 7 to the 7 to the third. Okay. So the answer would be 7 to the third. Okay. There we go. Now my question is, could I have done it a different way? Yeah. Because what's that equal to? 1. And then I could subtract that 1 from both sides, and I'd have log base 7 of x, and I'm subtracting 1 from both sides. 4 minus 1 gives me 3. And then I do a rewrite, and it's 7 to the third equals x. Same thing I just said. See, there's 2 ways you could have done that one. If you had simplified this part, it would have still worked out fine. But since these were both logs, I could add them together. All right, one more like that. It's a little less weird. Log base 3 of x plus log base 3 of 4, that way they can't simplify nicely, is equal to 1. Since there's no log over on the right side, you can't do the cancelable logs fake out thing. But you could do a rewrite. Once you get it down to 1 log on each side, but condense it, you could rewrite. Log base 3 of 4x is equal to 1. That part should have been easy. A lot of people get stuck right there. All I got to do is rewrite. Anytime you get stuck, look to see if it's possible to rewrite. 3 to the 1 equals 4x. 3 to the 1 is really 3 equals 4x. So then divide by 4 on both sides. X equals 3/4. Double checking it, I stick it back in and see, is there any chance that will crash something? Nope, it's okay to have a 3/4 there. 3/4. All right, let's do one where you need a u substitution. Log base 2 of x squared minus 2 log base 2 of x. Let me think. Minus 3 is equal to 0. And I have a hint for you. Let log base 2 log base 2 of x be u. So you clean this up and it turns into a nice simple equation with a u in it. Why do I use the letter u? Because that's the letter they use in calculus, the whole topic, u substitution. I tried to make this factor. Is it factorable? So then this part right here becomes a u, and this part right here becomes a u. So it's u squared minus 2u minus 3 equals 0. U and u, and then how do I factor that again? Minus 3 and plus 1? Does that work? Let me check it. First, make u squared, that's good. Outside and inside makes negative 2u. Looks like it works to me. And then the last, make negative 3. There we go, it worked. Yes, sir. We will not say you should use a u substitution. You'll have to figure out that, man, it would be easier if I used a u. You don't even have to. You'd have to just be able to factor this thing with log base 2 of x's right here. And that can work, but I think it's easier to just do it with u's. Nope, we're not done yet. So I factored it. Is that an answer? No. But if I get to the next step, which is that u minus 3 equals 0, so u must equal 3, and u must equal negative 1, do you get I'm getting closer to an answer? But still, I traded it, made this problem easier, so now I have to go back and make it harder. So, put it on the desk. All right, Mr. W, replace that u with what? Base 2 of x and log base 2 of x. And now I do a rewrite at the very end. Can you finish it? do it. From up here, I mean. I mean, you haven't got it yet, but you can just rewrite this. 2 to the, which is, yep, so what's 2 to the third? There you go. That's one of my answers, and the other one? 2 to the negative first, and that is, try again. 1/2. There you go. There's my two answers, 1/2 and 8. Now, right away, I don't automatically think one of these is going to crash me. So I look back at the problem and I see, if I ever had a negative here or a 0 here, I'd have a problem in both spots. But neither one of them is negative or 0, so we're good. No crashing. So there's two answers. That is called a U substitution, and that was the main topic for yesterday. Today's are actually easier than yesterday's because we don't have so many of these. One more like that. That's going to be a 3. Cases need to match. This one freaks people out. So you want to do a U substitution? You can't until you do one little thing. Who knows what that one little thing is? And then we can swap out a U for the log base 3 of x. Sir. Yeah, which two? The right one or the left one? Ah, close. The one on the right. I know the feeling. You want to get that one straight. All right. So the 2 goes down in front. And now I can do a U substitution. This kind, by the way, just so you know, you could not put the 2 down in front. There is no such rule. Only on ones where there's something on just the argument. If it comes from the argument, then it can go in front. All right, so now you get that this part right here is going to be my U, and that part's going to be my U. So I have, somehow I erased my 2 there, I got to get back. Okay, this is U right here. U squared equals 2U. And then you just have to solve it from there. So usually I say if you can factor, you should. In this case, you have to get it set equal to 0 first. Then you'll be able to factor. So you can finish the deal on this one. Let's pause for a second while I pair people up. All right, so here's how you do this one. You subtract 2u from both sides. You have u squared minus 2u equals 0. Why? You set it to 0. You always do. Whenever you're solving a quadratic, that's your first step. Set it equal to 0. Then you factor it if you can. If you can't factor, you got a quadratic formula. But I think this one factors. Then I go u equals 0. And the other option is u minus 2 equals 0, which of course would mean that u equals 2. Then I have my 2 answers. No, I don't. That's why you use u. Because if you see a u at the end, you know you're not done. Because the u means you substituted for something. And I put in, instead of log base 3 of x, I put in u. So now I have to pay the piper and put it back in. This becomes log base 3 of x equals 0. And log base 3 of x equals 2. So now, that. Okay, now I'm going to rewrite 3 to the 0 equals x, and 3 to the second equals x, and that's a 1 equals x, and that's a 9 equals x. Raise your hand if you had 1 and 9. All right, that's more than 3/4 of the class. Cool. All right. Any questions? Okay, so let's start your homework together. It's worksheet 16. Okay, let's pause for a second. Okay, so here's our worksheet. And we are doing number 1. Very first one, different than all the other ones we just did. Get the clump alone. That's a clump. Get it alone. So you divide by 3 on both sides. 6 to the x equals 90 divided by 3, which would be 30. Then, when you get stuck, you should rewrite. This is a rewrite. Log base 6 of 30 equals x. Now, some people might be like, but I don't know what the answer is. That is the answer. You can't simplify that one any further. And it's okay. If this had been like a 36, then we'd expect you to simplify it. But if you can't make the base and the argument get along nicely, then you can just leave it. All right, the next one. I'm going to divide out these next few are painfully easy. Just have to get the comp alone here, divide by 3 on both sides. 12 to the negative 1 is 1/12. I hope you know that. And then when you divide by 3 on both sides, you'll have 1/12 divided by 3. And again, you'll have to be able to handle things like that, a fraction over a fraction. You just flip them over. That becomes 3 over 1, and you flip it and make it 1 over 3. So then that ends up 1 over 36. Okay, final answer. 6 to the x equals 30, or 1 over 36. So then you should ask yourself, what's that? How about this? 12 to the negative 1. What's that? Another one? 12 to the negative 1? 1/12. You got to know what the negative 1 power means. It means 1 over. Okay? So this was 3, 6x. So all I did first was change that 12 to the negative 1 to 1. Next, I'm going to divide by 3 on both sides. Divide by 3. Divide by 3. And I was saying that this would turn into a flip and multiply. So 6 to the x is equal to flip and multiply 1/12 times 1/3. And then that becomes 6 to the x equals 1 over 36. Then I would say if you could rewrite that 1 over 36 as 6 to a power, your life would be really easy if you could just write that as 6 to a power. I think you can. This one, if you have decimals, change it to fractions. Because if I say log, and I always, another piece of advice, whenever you have no base, make the base 10. Anytime you have a fraction, make it, or decimal, make it a fraction. That is 1/100th. And now, hopefully you'll see that this number right here could be written as 10 to a power. Okay. Some more, a little further down. It won't let me delete the writing. Come on. There we go. Okay. Scroll this down a little bit. Try number 9. What happens if you won the argument in number 9? It's a really simple question. A lot of people get all twisted up thinking, how can I write a 1 as a 1/2 to a power? You can't. But, you could actually. But the answer would be 0. Okay. When I said, like on number 11, if you ever get stuck on one, like you might get stuck on number 11, you just rewrite it. So, rewrite. X to the 1 equals 10. Man, that makes it really simple, doesn't it? A lot of times, you're just rewriting things today. This one's x to the 2nd equals 25. Just remember, when you square root both sides, it brings in that plus-minus deal. All right. I need to leave the vast majority of them for you to handle. But remember those strategies that we gave you at the beginning? If you have 2 logs, always condense it to 1. If you get stuck, do a rewrite. And if they're really complicated ones that look like they have squared in them, then those are U substitution ones where you're going to end up factoring them. All right. That's my advice for today. And that's all I have for you for today.